today we are starting our review. Today is day 1 of review for our polynomials unit, and our test will be on Wednesday. So what we are going to start with is, we know about polynomials. We know that we want to create polynomials. What if, instead of starting with a polynomial, I gave you information and you tried to create the polynomial from that information? So, for example, if I said that there are some roots that I would like in my polynomial, and the roots that I would like are -5, -3/2, 0, and 2. And then I said I want my end behavior to, the thing I want about my end behavior is I definitely want the left side of my end behaviors to be pointing down. And I want a bounce, but I only want one bounce. And I want that bounce to be at x equals -3/2. So if I give you these 3 pieces of information, would you be able to create a polynomial that represents this information? Okay. So I will give you a few moments, and I will pause the recording while I give you time to work. Dice of Destiny, row 3, person 2. Can you tell us one piece of information about our polynomial? One thing. All right, there is an x plus 5. Awesome. Would you like to call on someone, or would you like another Dice of Destiny? Another dice. Row 4, person 3. We have an x plus 3/2. Is there a different way that other people might have written this? Yes, Olivier. You can also write this as 2x plus 3. Okay, either way. All right. Irene, would you like to call in somebody, or would you like a Dice of Destiny? Row 6, person 6. So since there's 4 here, that doubles back to the second person. One thing we could add. Right? We have just an x. Right? Would you like to call on somebody, or dice? Row 4, person 6, which will loop back up to you, right?
Me?
Yes.
Oh. What? Oh, there's an x minus 2.
There's an x minus 2. All right. So now it looks like we've got all our roots. There's a few things that we need to change or add.
I'll call on someone.
So, right? So right now we have all of our roots. If we have, for example, a bounce at -3/2, what piece of information do we need to add to our polynomial? So this one here needs to be squared. All right, because we need an even exponent. All right. Is there anything else that we need? I don't know. So if we don't know, we can always draw a picture. So let's see, we have -5, -3/2. We have 0, and we have 2, I believe. Yes? All right. And we know that, well, our only bounce will be at -3/2, and everything else will cross. What is the end behavior on the left? Down. So we know we have to start down. And what is the degree of the polynomial that we have? What is this degree here? What's the degree of this polynomial? Let's see, that's just 1. This is squared, so 2, 3, 4, 5. We have a degree of 5, so that's odd. If it is odd, do we have a positive or negative coefficient? Just 1, so that's positive. So positive, odd, what will our end behavior look like? This. So we start down, and then we end up, does it say anything about needing a specific end behavior on the right-hand side? It does not. So we can just finish off and say this right here looks like an acceptable polynomial. If we had decided, I want to square this, actually we wouldn't be able to because we only said one bounce, right? All right. But what if I said, I don't want this to be an x, I want this to be an x to the fifth? Would my degree still be odd? Yes. Would this create a bounce at 0? No. So we're still safe. This is also another acceptable polynomial. There's not just one right answer. Okay? Great. Show of thumbs. I am confident in what we just did, or I am shaky and I would like another practice problem like this. I need to see more thumbs to get an accurate representation. All right, let's do one more like this. Before we do one more, though, I just wanted to review one thing. If I have this as my end behavior, remember how we were talking about the mathematical way to write that? And it had something to do with limits. So I said, oh, I have the limit of my function. As x approaches, that arrow there means approaches, some value, it's going to equal some value. So over here, if I am looking at the end behavior on the left side of my graph, x needs to approach this direction. How do we say this direction in terms of a numerical or mathematical way? Exactly. Negative infinity. So if we have x, it's going to the left or to the negative infinity direction. What will my y value be as x goes to negative infinity? Just keeps on going down for forever. So what will our y value be? If it's going downwards for forever, it will indeed be going to negative infinity. Right. I would like you to try and write the limit version for this. I'll start you off. It always starts with limit, L-I-M, of our function. And then it'll have some kind of x approaches some value. And then it'll equal some y value. They will give you a few moments to try and figure that one out. So, dice, fourth row, second person. What is at least one part of this limit that you are sure of?
X goes to infinity.
So x will be going to infinity because it's going in the right-hand side direction. And then do you want to give a try for what y will be?
Infinity.
Y will also be infinity because as our x is going in indefinitely in that direction, in the right-hand side direction, our arrow upwards will continue to go upwards to positive infinity. All right? Okay, second example, like this. Let's say I have roots. And the roots I have now, I want one at -3, and I want one at -1. And then I want two more at 2 and 4. And my end behavior, I'm going to write as a limit. The limit of my function as x approaches negative infinity, I want to be equal to positive infinity. And then I want two different bounces this time. And I want those bounces at x equals -1 and at x equals 2. So let's look at this here, our end behavior. If we wanted to write this as we usually did with our arrows, if I have as x approaches negative infinity, is that going to be the left side of my end behavior or the right side of my end behavior? Left side of my end behavior. So you have my left side because of this. And then, because of that, all right? And then we need to figure out, is it going to be pointing upwards or downwards? And if we look here, this is at positive infinity. Is at positive infinity? That's the positive direction upwards. So with this, see if you can create a polynomial for this information. And I will pause while you do so. Right, this is Destiny again. Row 5, person 5. There's 3 of these. 4, 5. Franny. Heads back to you. Can you tell us just one part of the polynomial? You've got an x plus 3. Awesome. Do you want to call on someone or a dice? Right? Row 4, person 6. So that is you again, Ryan. So just another part for a polynomial.
Like x plus 1.
Got an x plus 1 squared. Got to bounce. Nice. Do you want to call on someone?
Caroline.
Caroline.
Next one's x minus 2.
Got an x minus 2 squared. Awesome, awesome. Do you want to call on someone or dice?
Yeah, Olivia.
Right, x minus 4. All right. Are we done? Is there anything that we need to add? Let's check. I don't know about you, but I like checking. Right, we've got -3 and -1, and then we've got 2 and 4. It needs to bounce at -1 and at 2, and then it just needs to pass through the other roots. Let's see. Our end behavior on the left-hand side is up. So if I'm looking at my polynomial now, and I look at my polynomial, what is the degree of my polynomial? Let's see. Olivia, would you like to call on somebody? Tell us what the degree. Want to roll? All right. Row 6, person 2. Do you remember how to find the degree? Just the degree of our polynomial. Got a degree of 6. So it's even. We have an even degree. What is our leading coefficient? Positive. So our leading coefficient is positive. We have an even degree. What will our end behaviors look like? Up and up. And does that fit with the end behavior that we need here? It does indeed. So because this end behavior right here works, then we can just continue with this problem. And it bounces off of those two, and then it passes through those 2 roots. All right, then it looks like our polynomial is finished. Okay. Now, from here, one last thing. Can you write the limit representation for this end behavior here? Okay. I'll start you off again. The limit of the function. What else do you need? I'll give you a few moments to do that. And I'll pause while you do. This is Destiny. Row 2, person 3. X approaches infinity equals infinity. Approaching the right-hand side, and it's going in the positive direction. Nice. Right. That is all the review we're going to today. Because it is a review day, you have no assigned homework, right? So what kind of math should you be doing tonight? Studying for your test on Wednesday. Make yourself a study guide. All those problems that we skipped, you should try them out. Okay? We will continue to review for tomorrow, but until then, we are going to be grading our tennis ball lab now. So if you could get your tennis ball lab up on your iPad, and once you have that done, if you could then move to the seat behind you, I will go get Mr. Server, and you will be able to grade your tennis ball labs. And that is it for now. So we'll pause while we grade that.